Okay, so this video is just a summary of everything in the MYP1 algebra unit. So what is algebra? Balancing equations, collecting like terms and brackets. That's basically everything in my MYP1 algebra unit. So to start with, what is algebra? So I've defined it. Algebra is a logical process of finding unknown quantities by substituting letters for numbers and manipulating equations. So that's chapter 1. It's just that single sentence. Make sure you get that jotted down if you haven't done so already. And then balancing equations. So in class we represented the equation 3x plus 2 equals 17 with jelly beans, and I represented the loose jelly beans, or I represented the numbers 2 and 17 with loose jelly beans, and I represented the x's, unknown quantities, as bags of unknown numbers of jelly beans. So 3x plus 2 was 3 bags of beans with an unknown quantity in, plus 2 loose ones, 3x plus 2, and then 17 was just 17 loose ones, and you know what they are. It's just 17. So each bag has x beans, and the loose beans represent numbers, and then right in the middle is the equal sign. So I'm representing an equation as a balance, and that's something I say throughout MYP. You've got to think of an equation like a balance, and whatever you do to one side, you've got to do exactly the same to the other side. So if we take 2 jelly beans from each side, the balance is maintained, and the concept of balance is fundamental to algebra. Whatever you do to one side of an equation, you must do exactly the same to the other side in order to maintain balance. So just going through the examples here. So 3x plus 2 equals 17. Take away 2 from both sides, 3x equals 15. Divide both sides by 3, x equals 5. So note how I've got everything nicely lined up here so it's easy to follow. Note how 3x means 3 times x. It doesn't mean 30 something. And note how I do these little notes on the side to show what I'm doing to both sides. That's, in my mind, a nice clear way of setting things out. And remember, you're doing things to both sides because it's like a balance and you've got to maintain the balance at all times. Here's another example. 8x plus 6 equals 18. I take away 6 from both sides to get 8x equals 12. So the purpose of that really was to get the 8x on its own. 8x equals 12. And then I don't want to know what 8x's are. I just want to know what 1x is on its own. So I divide everything by 8 both sides to get x equals 1.5. Another example. 5x plus 8 equals 15. I take away 8 from both sides to get the x bit on its own. So I get 5x equals 7. But I don't want to know what 5x's are. I want to know what 1x is on its own. So I divide everything by 5 to get x equals 1.4. Another example. 6x minus 4 equals 68. So again, I'd like to get the 6x bit on its own. So I need to get rid of the minus 4. I get rid of the minus 4 by adding 4. But because an equation is like a balance, whatever I do to one side, I have to do exactly the same to the other side. So I'm adding 4 both sides. And that gives me 6x equals 72. I don't want to know what 6x's are. I want to know what 1x is on its own. So I divide everything by 6 to get x on its own equals 12. So that was page 1 of that, and then just moving my notes on. If I can do that, here we go. So I've got more examples. 5x minus 2 equals 53. I want to get the x bit on its own, so I need to get rid of the minus 2. I do that by adding 2 to both sides, and I get 5x equals 55. I don't want to know what 5x's are, I want to know what a single x is on its own, so I divide everything by 5 to get single x equal to 11. So remember, an x on its own means 1x. Another example. Now we've got fractions. So x over 2 plus 11 equals 18. Well, the same thing applies that I'd like to get the bit with x on its own. So I want to get rid of the 11. So I take away 11 from both sides to get x over 2 equals 7. But I don't want to know what x over 2 is. I want to know what a whole big fat hairy x is. So I multiply everything by 2 to get a whole big fat hairy x, and that gives me x equal 14, because I've got to do the multiplying by 2 on both sides. Of course, you can always go back and check these. So if we think x equals 14 is the answer, then just go back and plug it in the original thing. So x over 2 would be 7, and 7 plus 11 does make 18. So we know it works. Another example. X over 7 plus 14 equals 22. So again, I'd like to get the x bit on its own, isolate the x. So I've taken away 14 from both sides to give me x over 7 equals 8. But I don't want to know what x divided by 7 is. I want to know what a whole big fat hairy x is. So I multiply everything by 7, both sides, and that gives me a whole big fat hairy x equal to 56. Moving on. X over 6 minus 4 equals 74. Add 4 to both sides to get the bit with x on its own. So x over 6 equals 78. I don't want to know what x over 6 is. I want to know what a whole big fat hairy x is. So I multiply everything by 6 to get a whole big fat hairy x, and do the same on the other side. 78 times 6 is 468. So multiplying both sides by 6, x equals 468. Another one, I think. Let's have a look. Oh no, so a new bit of the notes. Collecting like terms. So you can combine things of the same type. You can combine 2 bags of jelly beans with 3 bags of jelly beans, and it gives you 5 bags of jelly beans. So in a similar way, you can combine 2x with 3x to get 5x. 2x's plus 3x's make 5x's. And then also you can combine loose beans. So 6 beans with 9 beans makes 15 beans. So that's analogous to 6 plus 9 equals 15. But you can't mix them up. So you can't combine beans with bags, and you can't combine ordinary numbers with x's into a single thing, because they're not, they're not the same type of quantity. They're not the same type of quantity. So you can combine numbers. 6 plus 9 equals 15. You can combine x's. 2x plus 3x is 5x, but you can't combine the two things with each other. So here's an example. 2x plus 6 plus 3x plus 9 equals 55. So you can gather up the x's, the 2x's and the 3x together make 5x's, and you can gather up the numbers. 6 and 9 together makes 15. So that's gathering like terms, gathering things of the same type, giving you 5x plus 15 equals 55. So that simplifies it a bit. Take away 15 from both sides to get the x bit on its own, giving you 5x equals 40. And then you don't want to know what 5x's are, you want to know what a single x is on its own, so divide everything by 5 to get x equal to 8. X equals 8 is the solution. So here's a question. Solve 3x plus 4 plus 5x plus 6 plus x plus 8 equals 117. You might just want to pause the video now and have a go at that on your own. Okay, so moving on now. So gathering like terms, we've got an x, a 5x, and a single x, which is like 1x. So together they make 9x's. 5 plus 3 plus 1. And then the numbers, we've got a 4 plus a 6 plus an 8. So together that makes 18. So gathering like terms, 9x plus 18 equals 117. I'm going to take away 18 from both sides to get the bit with x on its own. So 9x equals 99. And then I don't want to know what 9x's are. I want to know what a single x is on its own. So I divide everything by 9 both sides to get x equals 11. Okay, so that's that bit, and moving on. A few more examples. So 3x plus 4 plus 2x plus 7 equals 71. Gathering like terms, 3x and 2x give you 5x, 4 and 7 give you 11. So that's the same as 5x plus 11 equals 71. I'd like to get the 5x bit on its own. So I want to get rid of the 11. So I need to take away 11. But because an equation is like a balance, I've got to do that to both sides. So taking away 11 from both sides, you get 5x equals 60. And then I don't want to know what 5x's are. I want to know what 1x is on its own. So I divide everything by 5. But because an equation is like a balance, you need to do exactly the same to both sides. So I've divided both sides by 5 to give me x equals 12. You'll notice how I keep saying the same things. That's just to try and get the routine to stick in your head. So I say things like, I'd like to get the bit with x on its own. I say things like, I don't want to know what 5x's are. I want to know what a single x is on its own. And above anything else, I say an equation is like a balance. Whatever you do to one side, you must do exactly the same to the other side. So I deliberately repeat these same old kind of cliche phrases over and over, hopefully so that a routine sticks in your head. Okay, so another one. 8x plus 3 minus 2x plus 31 equals 46. And whenever you see a minus, it belongs to the thing that comes next. So that minus, you've got to think of as belonging to that 2x. It's nothing to do with the 3. So gathering like terms, we've got an 8x and a minus 2x that together make 6x. We've got a 3 plus a 31 that together make a 34. And there was a 46 there. So 6x plus 34 equals 46. I'd like to get the bit with x on its own. So I'm going to take away the 34, but because an equation is like a balance, whatever you do to one side, you must do exactly the same to the other side. So taking away 34 from both sides, you get 6x equals 12. But I don't want to know what 6x's are. I want to know what a single x is on its own. So I divide everything by 6, both sides, to get x equals 2. Another one. Maybe you could pause the screen there and pause the video and have a go at that one yourself. But remember, these minuses, I'll put little brackets there to kind of remind you, belong with the thing that comes next. So 8x minus 3x plus 5 equals 80. So gathering like terms, we've got an 8x and a minus 3x that make 5x. We've got a minus 3 and a plus 5 that makes 2. So 5x plus 2 makes 80. I'd like to get the bit with x on its own, so I take away 2, both sides because it's like a balance. 5x equals 78. And I don't want to know what 5x's are, I want to know what a single x is on its own. So I divide everything by 5, both sides, to get x equals 15.6. So, answers can be weird decimals, sometimes negative numbers, 0 even. That's all perfectly possible. Okay, so I think moving on to the very last bit of this, and it's brackets in algebra. So the last chapter of my MYP1 algebra unit is called brackets in algebra, and when you see something in front of a bracket in algebra, the quantity outside the bracket is being multiplied by everything inside the bracket. So 3 brackets x plus 6 means that you've got to multiply the 3 that's outside the bracket by everything inside the bracket. So 3 times x is 3x, and 3 times 6 is 18. So 3 brackets x plus 6 means the same as 3x plus 18. And see how I've done these little color-coded annotations or notes to the whole thing to make that clear for you. So here's a question. Solve 3 brackets x plus 6 equals 120. So the first thing to do is expand out the brackets or multiply them out. So 3 times x is 3x, 3 times 6 is 18. So that's the same as saying, without the brackets, 3x plus 18 equals 120. And then it's just like solving any other equation. Take away the 18 from both sides to get the bit with x on its own. 3x equals 102. I don't want to know what 3x's are. I want to know what 1x is on its own. Divide by 3, both sides, because it's like a balance. X equals 34. Another one. Solve 2 brackets 6x minus 4 equals 7.6. So here's the answer. Expanding the brackets out, 2 times 6x gives me 12x, and 2 times minus 4, remember that's a minus 4, the minus belongs with the 4, gives you minus 8. So that's the same as saying 12x minus 8 equals 7.6. I'd like to get the bit with x on its own, so I'd like to get rid of the minus 8. I'm going to get rid of a minus 8 by adding 8 to both sides, remembering to do it both sides because it's like a balance. So adding 8 to both sides to get rid of the minus 8, we get 12x equals 15.6. But I don't want to know what 12x's are. I want to know what 1x is on its own. So dividing everything by 12, both sides because it's like a balance, that comes to x equals 1.3. And those were the notes for the algebra unit. So if you missed anything, do jot it down. I can make that available as a PDF